Okay, guys, we are back and we are picking up with the second half of area and circumference. Um, we have to be able to find the area and the circumference of a circle in order to succeed at the second part. We're going to add a step. So we're picking up with the same notes packet. I'm just scrolling down to the next part of it. So the first thing we're going to talk about is arc length. So we know that an arc is part of a circle. And so far, we've been measuring the arc in degrees. The measurement of the arc equals the measurement of the central angle. And that's not going to change. Now, what we're trying to talk about is the length. How far is it in inches or yards or miles? So think about a tennis ball. If we went halfway around a tennis ball, that's 180 degrees, and it might be 3 inches. But if we went halfway around the Earth, that's still 180 degrees, but it's thousands and thousands of miles. Very different in length or distance, even though it's the same degrees. Well, all we're going to do is we're going to find the circumference and then the part that we care about. So if you look at this example, what we have going on here is we have our circle and we have some basic information about it. Like, for example, AC equals 5. Well, AC is the radius. So that let us find the circumference. So that's yesterday's lesson, getting the circumference. What's happening now is we're going to say, well, instead of going all the way around it, start at A, and for example, let's go clockwise. We're going to go clockwise. So we're going to start at A, we're going to go through B, we're going to keep going around past D, come all the way back to A. Well, that would be circumference, 360 degrees. But this question asks us to find the length of arc AB. So if I start at A and only go around to B, I don't go all the way around the circle. So the question is, how much of that circumference did we travel? Well, think about it like this. The full circle, so the whole circle is 360 degrees. But we're only going to go from A to B. So in this question, we're only going 50 degrees. So we're going to go 50 degrees of the whole circle. So remember your is over of. 50 degrees of the circle. And that's the same as a certain distance of the whole distance. So very simple. The numerator is the part, the denominator is the whole thing. So look at my setup right here. Our arc is 50 degrees of the 360-degree circle. That is a certain part of the entire circumference. So 31.4 is the whole circle all the way around. That's why it's matched up with the 360. The length of our arc represents part of the circle, 50 degrees of the circle. That's why it's matched up in the numerator. And that's all the changes from yesterday to today. We're using yesterday's answer of circumference to find part of the circumference. Part meaning proportion. So we're just going to set up that proportion. Okay. And we're going to do the same thing in a few minutes with area. We're going to find part of the area. So check it out. We're going to build on yesterday's lesson. Yesterday, we took our radius again, and we found the area. So the area of the whole circle. So again, if I have a circle and I shade all of it in this case, that would be 78.5 square feet. But our question asks us to find the area of that pizza slice. So I don't want the whole pizza. I just want that part of it. Just like with length of an arc is part of circumference, a sector is a wedge. It's a slice of pizza out of the whole pie. So what we're going to do is we're going to compare the entire area to the part that we want. And we're going to set up a proportion just like we did for length. Notice the only thing that changes, if you compare the two slides, notice that the only thing that changed in our approach is that one number, because now we're doing area, and in the previous question we were doing circumference. That is the only difference. So in this question, the area of the entire circle is 78.5. That would be 360 degrees of the circle. But we're only going 50 degrees of the circle. So that slice of pizza is 10.9 out of the entire pizza, 78.5. Just think about it as that analogy. The circumference is the crust. The area is actually the pizza, the sauce, the cheese, the dough. And that's what we're doing here. So they work the exact same way. We're taking the answers of area and circumference from yesterday, and we're just putting it in this proportion. And we'll do one of each because they all work the exact same way. So the first thing we're going to do here is we're told km is 18. Well, directions are important. Km is 18. Km, that's the diameter. So we have to know what part we're working with. We're finding length of an arc. Length is part of circumference. So the first thing we're going to have to do is find circumference. So we're doing question A. Circumference equals pi d. So that's 3.14 times 18. So grab your calculator. And I have 56.52. That is the whole circumference. So that is 360 degrees all the way around. But in this question, we're only going from L to M. So arc LM, let's go to the picture. We have a central angle. Central angle equals the arc. So the arc we care about is 125. We have to be careful if it's a central angle or inscribed or anything else. So we have 125 degrees of the circle. And that equals what amount of the circumference? And we are simply going to cross multiply. And when we do that, we get 19.625 units, whatever they are. Now keep in mind, you're taking a part of the circumference, so your answer should always be less than the whole circumference. We would follow any directions that we were given, round to the 10th or the 100th or whatever it might be. So I might say our answer is 19.6 if we were rounding to the 10th units, whatever those units are. Okay. So that's how we're going to find the length of that arc. Now we're going to do the area of the sector KJL. So first of all, we need area. Area equals pi r squared. So 3.14 radius. Well, the diameter was 18, so the radius is 9. So we find our area. And our area looks like 254.34. And again, that's the whole thing. That is the 360-degree circle. But we only want KJL. KJL is this little sector right here. So the question is, how many degrees is that sector? Well, again, we're going to rely on our previous knowledge and our previous skills to say this sector right here, well, it wasn't given to us. We're going to have to figure it out. But if we look at it, we have a half of a circle. We know the red one, LM, is 125. So if we subtract that, 180 minus the 125, we get 55. So we know that this sector represents 55 degrees of the circle. So 55 degrees of the circle is what part of the whole area? And again, we're just going to cross multiply. So 254.34, cross multiply that. And since we rounded to the tenths before, I'm going to round to the tenths again. We would always follow directions. Remember, you're looking for a part of that area, so it's going to be less than the whole thing. So it looks like we have 38. And if I go to the tenths, it looks like 0.9 units squared. And that's the area of the sector. Okay. So again, we're using the answer for circumference or area, and we're putting it in the proportion. We have to figure out the measurement in degrees of the part that we care about. So that's going to rely on our knowledge about angles and arcs. And that's it. Okay, we're going to shut it down there, and you can do your practice problems for homework.